Welcome to this tutorial, a simplified presentation on what is needed for you to create a part program. What do you need for you to create a part program? Or what is this part program we are discussing? What do you require for you to be able to create a part program in, in CNC? I'll just explain in detail, be able to understand what CNC is all about. So let's go step by step. A CNC part program is a series of coded instructions which are required to control the movement of the machine. Once the table moves, it's able to shape the material desired, or it's able to cut the material to desired shape, or it's able to remove the material to desired shape. When we remove the material, we are subtracting. So normally machining, we call it subtractive machining. So this is subtractive machining. Subtractive machining. In subtractive machining, if you are using what you call a CNC, it automatically means you have a computer, and then you have numerals, numerical, then you have control. C means computer, N means numerical, then C stands for control. With the aid of a computer, you input an instruction which is coded. When you say coded, it has serials, it has numbers, it has digits. These digits are coming from numerals, letters, numbers, symbols. They have been put together. Each one of them have a meaning. They're able to control the table, move from point A to point B, and the speed of rotate, and also move up and down, or maybe alongside or in the opposite direction, so that you're able to cut the material to desired shape. Also, it has what you call symbols, which has its own meaning. In alignment language, a CNC is CNC part program. When they are calling the part, why do they call it part program? It means it is you are writing a program to produce a single component. That's why you call it part. Because you cannot machine assembly in a CNC, you machine parts, then you assemble them. So that's why you call it part program. When they say a series, there are many of them. This part, underline this, series of coded instructions. A series, it means is like a sequence. You are writing many of them. And what does it entail? Let's go to the structure of this program. Before we look at the structure, let's look at now the CNC part, the computer part. This is the computer part. If we are talking of a computer, which means this computer, it has the capability of allowing you to put the file or inside the file, or open the file, or link the file, or even write a program, either using USB stick, or you can use LAN cable, or you can use other means to communicate. If it's connected to Wi-Fi, you're able to connect your machine. If it's advanced, you're able to connect your machine to the source of the program. Once you put the program, the machine has this capability. The main part of the machine, the main brain of the machine is what's called MCU, Machine Control Unit. It has the capability of processing data and also controlling the movement of the table. That is why it has what we call control loop unit. If it is able to control, it can now issue motion data to drive the system, like motors, pumps, so that they're able to move from point A to point B, or even the pneumatic system. It has also other functions, miscellaneous functions, can help to put on the coolant, on off the coolant, and also ensure that the tool can also change. Maybe if it has an automatic tool change. It can also ensure that there's the change in tool, or the orientation or rotation of the tool. All these, they must relay information back the control loop system so that you're able to know what is happening. In case of any error coming there, maybe there's no lubricant, maybe the tool is bland, maybe the tool has broken. Some of them has sensors that may detect. Then it gives you feedback on the display, so that this one will read the program, read the error or the feedback, and then it is displays on the control or the display unit, so that you're able to know which which error has been displayed on the control and how can you rectify it. So that's why we're calling it a computer numerical control. All machines were using what you call NC. You are using DOS system, so they didn't have the capability of processing all this feedback. They are using what you call NC machines. But today you have what called CNC machines. Okay. When you look at the machine control unit, next is machine control unit. Normally, this is the heart of the NCNC, as I said, because it performs the function of reading the coded instructions. When you input the program, like this program, part program, you see here, like this part program is a part program. When you input this part program, it's able to read the program and then decode instructions, convert converts the program, because this is what you see. You as the operator, this is what you give the machine, and this is what you're able to see, and you're able to understand on your end. But when you give this program to the machine must read this program, and then it converts to a language called a 01 language. This one I don't want to explain in detail, but it's 01 language. Machine understand because the machine has been programmed using C++, Java. I don't know. Mostly, I think it's C++, C Sharp. When it is decoding instructions, it must understand if it is, let's say, G092, what does G092 mean? If it is if it is M03, what does M03 mean? It now sends the signal to the M03, which means the machine has an address. An address, they say M03. M is an address. That address is like a shelf. In that shelf, it has shelf from A, B up to Z. A up to Z. All these are address. So this address like the shelves. Then inside the shelf we have 00, we have 01, we have 02, we have 03, 04 like that. So 00 it has its own meaning. 02 it has its own meaning. So the machine, once it reads the instruction, it will send a signal to the address. Let's say M, and then we have 03. Go to 03. What does 03 means? Okay, according to my instruction, when I was programmed, 03, if it has M03, it means now start the spindle in the clockwise direction. Yes? Then it sends the instruction now to implement. It sends the instruction to the device needed. For example, if it is M03, start the spindle in clockwise direction. Which device should start the spindle in the clockwise direction? It is the motor connected to the spindle. Then the power must go to the motor, which is connected to the spindle. The spindle now rotates in the clockwise direction. If it was M04, it tells the spindle now rotate in the opposite direction, anti-clockwise direction. If it is M05, it tells the spindle stop rotating. So the machine control unit is very key in implementing the instructions as decoded from the data processing unit and control loop unit. So it will have to understand if it is interpreting now instructions to implement it. If, let's say, a purpose is linear, it knows G01 is for linear. If it is circular, it knows G02, G03 is for circular. At the same time, if it is helical, G02, G03 with a function for the helical, like IJK, will be able to initiate it to become helical. So every device that has been in that machine, it has a command. The command